Добрый день, уважаемые участники нашей секции. Секция называется «Агротехнологии», и с нашей точки зрения это одна из ведущих секций форума, потому что форум, который проходит под эгидой Росатома, он объединяет не только вот эти новейшие технологии, которые включают в себя индустрию Росатома, но, как мы все понимаем, что без продовольственной безопасности и еды никакие новые технологии эффективными быть не могут. Поэтому в рамках этого форума мы сегодня с вами обсудим те новшества, которые есть в области аграрных технологий, те очень интересные наработки, которые могут быть имплементированы в странах с жарким климатом, то, что может быть сделано в совместной коллаборации между нашими учеными и учеными африканского континента. Секция будет вестись на двух языках, русском и английском. Вы можете свободно говорить как на русском, так и на английском. Мы поймем друг
Вот, я буду сидеть в наушниках, слушать звук, приглашать, собственно, ну и раздавать роли.
Да, да. Ну, сейчас все разберемся.
Да, пока ждем людей. А не подскажете, Савченко будет присутствовать?
Да, она лично приехала, все, мы с ней списывались. Они, по идее, сейчас должны идти с этого.
Ну вот, собственно, и люди вот сейчас идут. Сейчас они уже
Сейчас у меня
заходят.
просто разбито на две части спикеры. У нас, говорю, вот у нас онлайн будет Оди Кристофер Джозеф из программы. Потом кто? Из первой части как бы все, остальные все лично. И из второй части, которая после обеда, ну, единственное, да, конечно, я надеюсь, что они сейчас подключатся, но в крайнем случае у них после обеда доклад. Сейчас найду их. Да, и после обеда у нас принц Асаби и Элзаят, да. А так, да, у нас, да, правильно, 3 человека всего онлайн, все остальные лично. Даниил, глупый вопрос. Я сейчас сижу, у меня на компьютере большая заставка, это заставка секции. А как мне поменять, чтобы, например, я видел саму людей как бы крупным планом?
А никак.
Никак, так задумано?
Да, это специально, чтобы люди не путались. Все, вот мы выключили. Это специально, чтобы люди, когда подключались, видели, куда подключаются, собственно.
I see our speakers and participants in the room. Hello, dear colleagues. Yeah, I see you. Unfortunately, I had no chance now to visit personally, so I will moderate online, and Natalia Savchenko will help me in person. Даниил.
Да, я тут.
На всякий случай спрошу, хотя сейчас исчезла. У Оди было что-то значок нестабильное подключение к интернету. Это означает, что слабенький у него контакт?
Да, это и с его стороны, у него проблемы с интернетом.
И тут, как бы, я так понимаю, ничего не сделаешь, либо они как бы у него исчезнут.
Да, либо ему нужно, собственно, найти Wi-Fi сигнал более четкий, стабильный.
Ну да, вот у него что появляется, то исчезает.
Мы, правда, ничего сделать не сможем. Это только с его стороны.
Я понимаю.
Он может понизить качество картинки.
Да, он может качество картинки понизить.
Ну, мне кажется, сейчас вот...
собственно, вот Оди подключился.
Оди, do you hear me? Could you turn on your microphone?
Не, у него сильно...
Yes, I can hear you.
Yeah, I see. I hear you okay. Actually, I see the sign that your internet connection not so stable.
Yes, but I can be able to make presentation with it.
But I hope anyway it will be enough for you to provide your presentation.
Yes.
Yeah, great.
Yes.
If we will have some technical problems, we will try to solve.
It's okay.
Yeah, great.
Okay.
Okay, thank you for your report. So I can talk. Thank you for your report. I'm really glad that I heard it. But I have one teeny tiny small question. Please, can you tell me where is the food consumption table taken from? So I'm interested in where is this data from?
We take us from different places and we go to the residence and say that can you take us for the analysis, and they get our potato. Also they take us carrot, fish, but they're very small samples and we don't can analyze it there. So the people interested in why we take these samples, and we say that is for our research work, and they help us very much.
So thank you for your answer.
Thank you.
Thank you very much. Yes, please.
Okay, thank you for your presentation. My question is about the preparation of the sample. Is there a reason why it wasn't air dried and mashed before reading the sample, but you just cut it into tubes and place it in the beaker? Is there a reason? Thank you.
You ask about population calibration, yeah? For example, for first.
Yeah, could you repeat your question, please?
My question is that why wasn't the potato air dried and mashed before taking the reading, but rather it was just cut and you took the reading directly?
We take off samples from Kaluga region. We take in the package, and from car we go at our to see institute, and other we cut them and do our analysis.
Okay, thank you very much. I see that it's interesting discussion on your topic because it's very important to perform the investigation on the food safety with association with some nuclear consequences. Thank you very much for your presentation, and let's try again to see our guest online from Zimbabwe. Dr. Pfiri, are you with us? Professor Pfiri? No connection yet. So let's go to the next presenter.
Our next presenter from Egypt.
So Tavardes Mina
Sami Bolis with topic plasma disposal of radioactive materials.
Здравствуйте. Слышно, да?
Да, добрый день, хорошо вас слышим.
Все хорошо. Hello, everybody. My name is Mina. My work is about plasma disposal of radioactive wastes. And for the beginning, we have to get in touch with what is the radioactive materials. The radioactive materials are any materials that are containing unstable atoms that emit ionizing radiations as it decays. And there is 3 types of radioactive materials: gaseous, liquid, and solid. And methods of the disposal of the radioactive materials, we have too many methods. One of them, discharge into the ground, discharge into water, disposal in the air, and plasma, which I studied, and chemical disposal. And one more, it's burning in air. the purpose of the work, it was studied to show the results of effectiveness of plasma processing on the radioactive materials. For the task, we had 3 tasks. First, we changed the current, and so the effect of plasma by changing the current from 50 amperes till 100 amperes. And the second task was to change interval time of the processing of plasma from 10 seconds, 20 seconds, 30 seconds, and 40 seconds. Предыдущий слайд, да, еще и сюда. Вот. And можно следующий. Вот. And the materials we studied was 4 materials, biological materials of animal tissues, soil, sand, and glass. And here I want to say why we didn't choose something like trees, because plasma processing for the trees will be have no sense, because it will be instantly flammable. So we can't see the effect of plasma on such materials. Следующий слайд, пожалуйста. Вот. The installation I worked on, it has this shape. Down here we can see the anode and cathode, and in the upper photo is the installation itself. This installation, it allows splitting the complex polymers to gaseous hydrocarbons and carbon monoxide. And then we have to move to the results. Еще слайд, пожалуйста. Еще. Well, the results of the soft animal tissues under the effect of current change, we found that the current 50 amperes, the initial sample was 2 grams, and the 50 amperes current was exposed to this sample, and at 10 seconds, the initial mass became 0.62, and after 20 seconds, the mass was like 0.53, and after 30 seconds, the mass became 0.45, and 40 seconds, the mass became almost 0.41 or 42. It is all under the 50 amperes, 75 amperes the same, and 100 amperes the same. I mean the same experiment, not the same results. And the result of the 100 ampere, it was under 40 seconds, almost 0.017 grams left. The plasma processing on the soft animal tissues showed effectively results, and the sample mass change reduced by 96% to 99% respectively. Еще следующий слайд, пожалуйста. And here we changed the time interval from the 10 seconds to 40 seconds under the plasma effect of 50 amperes and 75 amperes, 100 amperes, and these are the results. The change of mass under the 50 amperes was 96.97%, and for the 75 amperes, it was 99.82 amperes, and for the 100 amperes, it was 99.83%, respectively, under the 10 seconds. And for the 40 seconds, the results was for the 50 amperes, 97.94% change in mass reduction. And for the 75 amperes, it was 99.90%. And for the 100 ampere, it was 99.91% mass reduction. And the next sample will be the soil. The same experiment was done. And here we found the reduction in mass was 28 pi till 83% respectively from 50 amperes to 100 amperes at the intervals of time 10, 20, and 30 and 40. Next slide, please. Oh. The next sample was sand, and the reduction in mass was only 12% under the plasma installation from 50 amperes to 100 amperes at the time intervals from 10 to 40 seconds. And as for the glass was changed only or reduced only by 4% as from the same intervals of current and time. Here we can see the effect of the plasma after 10 seconds on the four materials: animal tissues, soil, sand, and glass, under the 50 amperes, 75 amperes, and 100 amperes. The change of the animal tissues after 10 seconds is almost 99.9%. And as for soil, it was from 28 till 53% under 10 seconds of plasma treatment. And second one is after 20 seconds, the change was the same for the animal tissues, and it was 99% reduction in mass. And the sand and glass are almost by 4 and 10% reducted in mass. Here is the analytical expression that connects the time with current soft animal tissues. The first line is equation which we use to find the mass reduction. Here you have to put the time on the first line. If you have 10 seconds, 20 seconds, 13 seconds, 25 seconds, you just substitute with the time and you will find the mass reducted according to the soft animal tissues. And the second line for the sand, first column is 50 amperes for 75 amperes current and 100 amperes current. The second table is for the time. If you have a current, you have to substitute with current. After 10 seconds, you will find the mass reducted for soft animal tissues and sand, soil, and glass. Conclusion, we have the efficiency of plasma processing of radioactive materials has been experimentally proven. The plasma processing on radioactive animal tissues allows to reduce their mass by 96 to 99% at the same time. And the duration of the processing can be no more than 10 seconds at the current strength of 75 ampere. And the plasma processing of radioactive soil allows to reduce their mass by 28 to 83% at the same time. The duration of processing of the current strengths may be greater than ranges studied, and this can reduce the amount of original sample by more than 83%. And the plasma processing of the sand, it reduces the mass by 12%, and at the same time, and increase in the duration of the processing and the current strengths don't have a greater effect. And the plasma processing of glass allows to reduce their mass no more than 4%. At the same time, an increase of the duration of processing and the current strengths, in this case, don't have a greater effect. And analytical expressions formulated to assess the effect of the current strengths and the processing time of radioactive materials on the change in their mass. Their use in the practice will make it possible to make a prognostic analytical analysis of the reduction in the amount of radioactive materials studied. I took part in 3 conferences in Moscow, Tomsk, and St. Petersburg. The first was in Rodian, 25th of November, former Africa. The second was in Tomsk, 13th to 15th December. And the third is Command 2023 in St. Petersburg.
Thank you.
You're welcome.
Thank you. Any questions? Please.
Please switch on your microphone. Yeah.
Thank you for your presentation. And my question is, we saw that there were reduction in the masses of the various sample study. How were you able to measure that this the reduction in mass is specifically the reduction in the radioactive samples in your studied subjects? Because we know that these substances are not made up of only radioactive substances. There are other components. How did you accurately determine that the plasma processing was as a result of the reduction in mass was as a result of plasma processing?
Look, we had the initial mass of the sample. It was 2 grams. When you find the resulting mass is 0.6, 0.5, 0.4, 0.7, it's already a reduction in mass. So the process of plasma, it allows you to decrease the reduction of mass. You reduce the mass, so you can easily make a disposal of these radioactive materials.
Okay, thank you.
I have small questions. The excellent results, but how expensive this method, and its use economically beneficial?
Can you repeat your question, please?
You have excellent results, but how expensive this method?
This method is by experimentally it costs me not too much because I used a small samples by 2 grams, but in the real life it will be expensive because you will treat the materials not by 2 grams, but the material as it is. So you will need a more bigger installation to use the materials under plasma.
Mm-hmm. Thank you.
Thank you very much. Yes, of course, the issues of economic performance, it's also very important. However, the effectiveness of methods that you have shown that it's very high. So let's try again the fortune. And dear Dr. Anthony Fury, are you with us?
Yes.
Oh,
Can you hear me?
thank you very much. So, dear colleagues, let me give the floor to the Professor Anthony Pfiri from Zimbabwe. He is the director of the Environmental Management, Renewable Energy and Climate Change Center from Harare Institute of Technology. And the topics of Professor Pfiri is also devoted to the nuclear waste disposal. So it's some interconnection between these two topics. So, dear Professor Pfiri, the floor is yours.
Hello?
Yes, we can hear you, and your presentation is on screen. Can you see it?
I can't see it at the moment. Let me put it on. I'm putting it on. It's going on. While it is it's going on, I would like to thank the organizers of this platform. Good morning, colleagues. My topic is Zimbabwe Prospective Radiological Environmental Impact Assessment for Facilities. As we all know, dealing with nuclear material is delicate and has got various potential impacts. And it is important and to go through the analysis before anything is done. I would like to first of all talk about Zimbabwe as it is in terms of its location and its potential to deal with power generation from nuclear. Zimbabwe is a landlocked country in southern Africa between Zambezi and Limpopo, and bordered with these countries Botswana, Zambia, Mozambique, and South Africa. And its capital is Harare, and it's got about 15 million people. As well, it is an agrarian country. I'd like to just bring about a brief background on the nuclear power source. The first commercial nuclear power station started operation in the 1950s. That's long back. And nuclear energy now provides about 10% of the world's electricity from about 440 power reactors. Nuclear is the world's second largest source of low carbon power, 26% of the total in 2020. International energy status, with a combination of industrialization, economic development, and projecting doubling of world's population in 2050, global energy consumption will surely increase. And the only option to increase the power generation is the use of nuclear energy. Nuclear power generation process is principally basically use the energy released by splitting the atoms of certain elements. It was developed in 1940s during the Second World War. Research initially focused on producing bombs, but as it now we are more focused on the sustainable use of the nuclear energy to buttress the sustainable development goals. In fact, through initial transmission grids, many more countries depend in part on nuclear generated power. Talk of Italy, Denmark, for example, get almost 10% of their electricity from imported nuclear power. You see how important the nuclear power is revolutionized the development throughout the world. In Africa, only 11 research reactors currently exist across the African continent. Only 11 covering the wild power range from 0.1 kilowatt to 22 megawatt. South Africa, the only country with a nuclear power plant owned and operated by state-run power unit ESCOM, is the only nuclear power plant that on the continent. It has an installed capacity of 1,940 megawatts. Does Zimbabwe need nuclear power? Obviously, Zimbabwe needs nuclear power. If you look at this graph, we say in 2000, we would only, the whole country, electricity generation for the whole year, into the year 2000 was 6,000 terawatts an hour. And as you can see, the graph goes up and down, and that will demonstrate how much challenges we have experienced where the graph is going down, and which will mean that the economic development also as well goes down. And now let's look at 2020. The power generation for this whole year 2021 is below 8,000 tetrawatts an hour, which is far below what the country needs. When countries get their power from coal, from oil, gas, wind, hydro, and so forth, it's usually some combinations of some of it which provides energy. But it is critically important to have a good energy mix. For instance, as it now, The balance of source of energy supply is increasingly important as countries shift away from fossil fuels towards low carbon sources of energy. In that regard, nuclear or renewable, including hydropower and solar and wind, are very critical for sustainable development. To reduce carbon dioxide and exposure to local air pollution, we need to transition our energy systems away from fossil fuels towards low carbon sources. Low carbon sources include nuclear and other renewable energy technologies such as solar. And of course, we have got hydro, we have got wind, and so forth. Zimbabwe's ambition is to achieve targeted sustainable development goals, as well as low carbon development mechanism. In accordance with Zimbabwe's renewable energy policy, Zimbabwe is focused on developing an efficient funding mechanism that can enable implementation of nuclear energy plants. Nuclear energy is the solution to low carbon development. Nuclear energy power has got its own challenges. The accidents associated with nuclear energy are disastrous. Uranium decomposes into harmful subatomic masses. Accidental leakage of radiation and large-scale accidents can be catastrophic, and this can happen during the transportation, disposal, and operation of nuclear energy plants. It is important for various countries to invest in these aspects to create separate in the generation of nuclear energy. Because it has got some need for new power plants, large size, high investment costs, and it is important to come up with the smaller nuclear power plants which has got low investment, which is not prohibitive to their development. Like nuclear energy issues have got large operating costs may lead to ignoring a certain standard operating procedures by the staff if they are well trained or they don't have a great background. And so it is important to invest in the training of the cadres who have to work within this space and to create a safe environment. Environmental impact assessment. For a case study of Zimbabwe, it is important to focus on a well-researched environmental management plan within the environmental impact assessment to mitigate various risks systematically. Nuclear waste disposal. An integrated transport system of used nuclear fuel and centralized disposal with future plans is critical to invest in. Development of new nuclear reactors and funding of smaller reactor designs helps reduce construction time and cost and make it viable. With the strict maintenance and regulations, there is need for staffing, training, regular inspections, and costly to operate. So, as you can see from the environmental impact assessment, there is much which is needed to be done in the environmental management plan to focus on the resources development, especially human resources, which can manage the various aspects of development, transportation, and disposal of nuclear waste. In conclusion, I would like to say that nuclear energy is one of the few sources of electricity that does not release any carbon into the atmosphere. Nuclear energy production is incredibly reliable. Nuclear energy typically has some of the longest uptimes rather than any other energy sources. They can operate 24 hours for 7 days a week, and the refueling can be done in only 1.5 years to 2 years, and it's available at least 92% of the time during the operation. Nuclear energy is a reliable, affordable, and versatile energy source. The technology involved in its production continuously improves to make sustainable, safe, reliable, and require robust, sound in investment in research and development, and creates a cleaner environment without damaging our economy. Abundance of resources exists in Zimbabwe, which has not been tapped because of various challenges. Within the Zambezi River Valley, in the north of the country, we have got the uranium deposits, which needs to be tapped. But very important is to go through a sound environmental impact assessment before anything can be done. Thank you.
Thank you. Any question? I want to ask, we see that there are two problems with waste, nuclear waste, and problems with climate change. How do you think nuclear energy can be called? Hello?
Hello?
Dear Dr. Pfiri, can you hear us?
Hello?
I think no questions. Oh. Hello?
Yes, I can hear now.
Dear Dr. Pfiri, can you hear us?
I can hear you now.
Oh,
But
that's
the
perfect.
person wanted to...
Yeah, my co-moderator has a question, please.
One question, how do you think nuclear energy can be called green energy?
It's green energy because it won't be there won't be any carbon emissions, and there's no threat to the environment, and so it's a green energy.
Yeah, okay, thank you. Thank you.
Thank you very much once again for such interesting presentation with some integral vision of the nuclear energy in Zimbabwe. And now let's move to the North Africa to the next presenter, Saif Eddin Ejdai from Tunisia. He is a master student of the Environmental Engineering and Ecotechnology Laboratory from University of Sfax. Dear Saif, the floor is yours. Dear Saif, you can start.
So we have any effort to come up with
Dear Saif from University of Sfax, are you with us? Dear Saif, if you are with us, please send some message in the chat because we cannot hear you. So I propose to, if it's some problem with connection, to move to the next presenter, also from online. Kakbet Aaron, are you with us? Not with us. So I suppose that we can move to the next presenter from offline, Sadamon Mark from Benin. He's PhD student of the Department of Building Materials Science, Moscow State Construction University. Please, Mark, the floor is yours.
Thank you. Good morning. Good morning, everyone. I'm here today to present our research entitled with thermal decomposition of modifying stems of Sosnovsky hogweed by monoethanolamine 3-hydroxyborate. The purpose of this research was to determine the decomposition temperature as well as the mass losses of the main chemical component of crushed stems of Heracrin Sosnovsky modified with a 4-coordination borasium component by thermogrammetric analysis in order to increase the stability of plant raw material for the production of building materials. In order to realize the set objective, the following tasks were to be solved. Identifying the pattern of interaction of monoethanolamine 3-hydroxyborate with lignocarbohydrate complex of Heracrin Sosnovsky cell walls. Thermal analysis of crushed stems sample, modifying and unmodifying monoethanolamine 3-hydroxyborate. And the last task is determining optimal concentration for modifying of raw material by monoethanolamine 3-hydroxyborate. Heracrin Sosnovsky is become an environmental catastrophe. As such, scientists are searching to possible application of Heracrin biomass in engineering, paper and paper production, medicine and the pharmaceutical industry. The porous microstructure of hogweed stems has spiked the interest of scientists in the material as an additive to concrete, which reduces its thermal conductivity. Active growth of fungi on most stems surfaces of the plant is common. Hence, the need for pre-treatment with antiseptics. Application of our of 4-coordination borasium component, monoethanolamine 3-hydroxyborate, for modifying cell walls of Heracrin stems will enhance 100% biostability for a period of at least 20 years. The knowledge of the conduct research is lying in the substantiation and the experimental confirmation of the possibility of increasing the biostability of plant raw material, Heracrin, determination of optimal parameters of modification process, the proposition of production condition for thermal insulation composite material based on crushed stems of Heracrin Sosnovsky modified with monoethanolamine 3-hydroxyborate. The research methodology were presented in this slide. The last point is investigation the surface layer of samples by the method of infrared spectroscopy, electronic microscopy, and thermal analysis. In this slide, it shows the microphotography of modifying and controlled samples with 500 times magnification. It shows that in this photography we see the distribution of modifier in the intercellular space in observed. In addition to this, the higher modification temperature of most saturated near-wall layer by modifier molecules. We have free concentration of modifier, 10%, 30% and 50%. And the future one present the weight gain of a sample after modification, extraction, and drying by different temperature modification. It's true that when we modify with 25 degrees Celsius and the drain with same temperature, they give us enough weight gain who was like 44%. Also, we make the analysis infrared spectra of modifier and the control separates. It is shown in the figure 3 that the change in the peak, the range of 1,315 to 1,470 has also undergone a change. The change provide that for all for the picture 3.2 and 3.4, we see the change, and also for the figure 3.1. It's this with the absorption band, it apparent satisfies the presence of coordination bond borate nitrogen in composition of modified bases. Also can also observe the appearance of band in range of 1,630 centimeter by centimeter, which correspond to the effect of bonding amine.
Dear Mark, I'm sorry to interrupt you. The time limit, please.
Okay, in this slide, we present the result of biostability of assessment according to GOES. And we see that when we use 30% and 50% of modifier, they give us 100% biostability. Also, we make a thermal analysis who present in this slide, and we make the analysis in this table. It's sure that we have a free stage, the stage from 50 degree to 250 degree, who correspond to the decomposition of water, and the second from 240 to 320 degrees Celsius according to the composition of hemicellulose, and the third stage is from 320 to 560, who correspond to the composition of cellulose and the lignin. The conclusion of our research, we have three principal conclusion. During modification of crush systems of Heraklin Sosnovsky, the polymerization of lignin and the hemicellulose occurs, and the modified molecule replace them in the composition of the cell wall, lignin carbohydrates complex. This process is reinforced as the aqueous concentration of the modifier increases, leading to a higher content of boration nitrogen component in the base composition. The process of dipping paint raw material in monoethanol amine trihydrous borate is accompanied by chemical substitution. This is evidenced by the presence of modifiers molecular confirmed by the data of infrared spectroscopy and the microphotography. in the intercellular space after continuous water extraction. And the last conclusion is when modifying, when we use monoethanolamine to modify the plant around, it is give us the possibility to get 100% biostability by the using 30% modifier. Thank you for your attention.
Thank you. Do you have any questions? No.
No questions. So many thank you for your very interesting investigation, because this trouble, we all see this trouble that you have mentioned. And maybe you have some comparative analysis of others' research.
Yeah.
Yeah. And what is the difference between your results and their results?
The difference is that we are the first scientists who want to use our round material. It is the name in Russian is Bolshevik.
Yeah. We know it.
To create material like thermal insulation. Nobody, how to say, before don't use our modifier to create another material.
So it's great scientific novelty. Congratulations.
And we get also the sample. Now we want to know when we want to produce our material, the condition that we dry the material in the, how to say, industry like this. By the way, we make this analysis to know with what temperature we can use modify and get our material.
Yeah, it's a very interesting proposal to industrial partners too. Thank you very much for such a great presentation. And now let's try again the online connection with Mr. Saif Eddin Jdai from Tunisia. Dear Saif, are you with us?
Are you hearing me?
Hello.
Hello, everyone.
So,
what is my... Sorry.
So will you share your presentation by yourself? Yes.
Yes.
Okay, we will wait. So I will remember to colleagues that Saif is from Environmental Engineering and Ecotechnology Laboratory from University of Sfax, Tunisia. So Saif, the floor is yours.
Thank you.
Thank you.
My name is Saif Eddin Jdai. My topic is the environmental impact of Tunisian hemodialysis unit as determined by life cycle assessment. We hear the outline. We have the introduction, the life cycle assessment and its definition, and how performing a life cycle assessment. And finally, we have a conclusion. Let's start with the introduction. The chronic kidney disease is one of the world's major public health issues. Over 2 million people worldwide now require renal replacement.
Saif, I'm sorry to interrupt you, but could you share full screen your presentation, because now we see only your first slide.
I share the presentation, but
maybe it will be better if we will share your presentation, okay? Please wait a minute. Can you see your presentation?
Can you see it?
Yeah, but can you see the presentation? Because now we are sharing your presentation.
Okay. Let's start.
Yeah, let's start.
The introduction here. The chronic kidney disease is one of the world's major public health issues. Over 2 million people worldwide now require renal replacement therapy to maintain their lives. In 2022, Tunisia had 12,000 hemodialysis patients, and at present there are more than 116 hemodialysis centers operating. Consequently, hemodialysis therapy is gaining growing significance globally. However, this treatment is highly resource intensive and places significant strain on natural resources such as fossil fuels, water, and forests. As an illustration, a patient undergoing hemodialysis may come into contact with 300 to 600 liters of water of an average weekly basis, earning it the label of a water-hungry therapy. The problem at hand is this intensive therapy can have a number of environmental consequences, particularly wastewater and greenhouse gas emissions. As a result, we must quantify those environmental impacts. For that, many studies have been conducted around the world to date to measure the environmental impact using various methods, with one of the most important being the life cycle assessment. Now, what is the life cycle assessment? The LCA, as defined by ISO 14040 and 40044 standards, is the compiling and evaluation of the inputs and outputs on the potential environmental impact of a product system during its lifetime. How to performing a life cycle assessment? A complete LCA has 4 basic components: goal and scope, inventory and data collection, life cycle impact assessment, and finally we have a result. At first, we have a goal and scope. The first stage of an LCA is to set goals.
Dear Saif, I'm sorry again to interrupt you. However, we cannot see your presentation. Please, could you switch off your presentation and we will share with our computer, okay?
Wait, okay.
Okay, please wait a second. So now we are sharing. Can you see the presentation?
Okay. I see it.
Next slide.
Now?
Yes.
The first stage of an LCA is to set goals. The purpose of this study was to calculate the environmental impact of hemodialysis as renal support therapy. The functional unit here is artificially replace kidney function in a patient using a hemodialysis machine for 1 session. In the city of Sfax, especially at hemodialysis clinic, there is an annual average of 75 to 80 patients, and the clinic conducted more than 13,000 hemodialysis sessions in the year 2022. We have system constraint. At this stage, we use the gate-to-grave system to gain a better understanding of the environmental effect of the hemodialysis process, like this diagram showing the stage and unit process of hemodialysis. Secondary phase, inventory and data collection. This phase of LCA involves the compilation and the quantification of hemodialysis inputs and outputs for a given product system throughout its life cycle, like this picture showing. This slide shows the table of water and electricity consumption and hazardous waste production in the artificial renal surface of nephromodialysis clinic in 2022, like this table shown. Here we have the hemodialysis diagram of I was created in Gabi software. The third phase is the life cycle impact assessment. This chapter is devoted to the third phase of an LCA study, the life cycle impact assessment, LCIA, in which the information from the life cycle inventory and on elementary flows is converted into environmental impact scores. The recipe midpoint method was chosen to translate the inventory's information into a limited number of category and indicator results. Now we have the results. First result is the climate change. This indicator refers to the increase in average global temperature as a result of greenhouse gas emissions. Like you see here, the most important emission is coming from the truck. by 4.7 kilogram carbon dioxide or transport. The second result is fine particulate matter formation. This indicator measures the adverse impact of on human health caused by emission of particulate matter. Also, we have the transport. The most important emissions come from the transport. And the third result is the freshwater ecotoxicity. Here we have the wastewater treatment are the higher value. And also we have the diesel mix refinery. We have the unimportant important value. And the last result is the human toxicity cancer. Also we have the wastewater treatment have the most important value. And we have also the diesel at refinery mix. And finally, we have conclusion. This study presents an environmental assessment of kidney care utilizing the LCA approach. Consequently, a multitude of solutions need to be explored to address these environmental challenges, including the implementation of a water treatment plant for water use. Additionally, there is a need to minimize greenhouse gas emission arising from transportation and electricity generation. And thank you.
Thank you very much for such interesting investigations. We all know that life cycle assessment now is one of the most important tool, and including the green economy, circular economy concept as well. Thank you very much. It was very interesting. And dear colleagues, do you have any questions? My question is, so I know that when we are talking about the life cycle assessment, one of the core step is inventory analysis. Which data you have used?
I was used the Gabi software, and I was choosing the recipe midpoint. This method for translate this indicator, this value.
So you have used some data set, especially on the hemodialysis equipment?
Not especially, but one of data, but because they have many data to use it.
Yeah, we know. Thank you so much. Very interesting results. Thank you. And now I suppose that we can move.
Let me introduce our next speaker, Emmanuel Kormla Danyo from Ghana. This topic, the effect from Ural Federal University, this topic, the effect of ionizing radiation on the viability and metabolic activity of beer yeast,
Saccharomyces cerevisialis.
SRF S33, please.
Activity
Dear Daniel, please switch on your microphone.
of Saccharomyces cerevisiae, SAF-LS33. Thank you. Yeast are microorganisms that play a very important role in microbiology, biotechnology, and used in the production of several food products, ranging from beer, Japanese sake, miso, etc. They are unicellular microorganisms that play a critical role in ethanol production and for food fermentation. They are also used as model organisms to study the environmental response pathway in many microorganisms. They have because they have been used for ages to produce food products, they have gained the designation generally regarded as safe. Now, apart from the conventional application of yeast, in modern biotechnology, they are used for production of metabolite, biotransformation, and production of recombinant proteins. Now, the aim of this work was to evaluate the effect of low doses of X-ray radiation on yeast starter culture to determine whether this could have any stimulatory effect on the viability and metabolic activity of the yeast. And why radiation? As a biotechnology, I am interested in the improvement of microorganisms using radiation, and mutations can be caused as a result of exposure of microorganisms to stressful environmental conditions to stimulate the production of novel chemicals, microbial metabolites, and in some cases, to lower the production of toxic metabolite during fermentation. And so in this work, however, when you apply radiation to microorganisms at higher doses, the microorganisms get inactivated or they die. And so in this work, we try to expose the microorganisms to low doses of radiation so that to create a stress environment for the adaptation to see whether their metabolism could be improved. The irradiation was carried out at the Institute of Physics and Technology at the Ural Federal University. After the irradiation of the microorganisms, we determined the viability of the yeast. We determined the generative activity by culturing the microorganisms in wet medium for 7 days. Each day, samples were drawn for analysis. And then we also did the acidification test to determine the amount of glycogen consumed during the lag phase. And then we also determined the enzymatic activity. Now, after growing the yeast on agar for some time, for 3 days, we observed that the control sample had the highest amount of colony count compared to the irradiated samples. Interestingly, the 20 centigrade exposure had the least colony count. Now, we determined the generative activity of the yeast. This measures the ability of the yeast to divide to produce new cells for the conversion of sugar to ethanol and other acids. So in the curve, the black curve signifies the control sample. So the control sample had higher amount of live cells compared to the irradiated sample. Yet also we saw that the number of live cells in the 20 centigrade exposed sample was less than the other samples. Now, another phenomenon we observed in this curve was that as we grow the organisms for some days, we saw that there is an increase in the number of live cells, and then later there is a decrease. Now, what could be some of the reasons accounting for this? So we observed that, okay, the osmotic stress when microorganisms are in nutritional medium could affect the live cells. So if microorganisms are not able to adapt to the osmotic stress, they will die. However, microorganisms that are able to adapt to this condition will begin to increase in number of cells. Also, we determined the sugar consumption rate by the yeast, and we observed that the control yeast had a very effective way of consuming sugar in the medium, which is the black curve in the middle graph, the black curve. And it makes sense because they have more number of live cells, so obviously their sugar consumption should increase. Here also, we saw that the 20 centigrade sample had the least sugar consumption potential. And also, we determined the dry cell mass of the culture. We observed that the control sample had the highest dry cell mass compared to the samples irradiated. Now, we determined the amount of glycogen consumed by the yeast in the lag phase. Now, if you look at the table, you will notice that after 5 and 10 minutes, the pH increased. Now, our expectation was that as the yeast is in the medium, or without any nutritional medium, it should be able to break down glycogen to produce ethanol and some organic acids to decrease the pH. However, looking at the table, the pH increased after 5 to 10 minutes. And we were trying to think what might be the reason because it goes against our expectation. So one of the reasons we identified was that probably the manufacturer of the starter culture harvested the yeast at a stage where the microorganisms could not accumulate more glycogen in their cells. So therefore, you can see that the yeast has little or no glycogen in their cells. Now, after 10 minutes, we added glucose, and we saw that the pH now began to drop. So if you look at the curve in the middle, the pH decreased after 30 minutes. Now, here also, you can see that the red curve, which is the 20 centigrade, had the least sugar fermentation potential. So we use the change in pH to determine the viability of the yeast cells. Here, the control sample yeast cells were more viable compared to the irradiated samples. Here also, the 20 centigrade cells were not as viable compared to the 40 and 60 centigrade radiation exposed cells. Now, we determined the ability of the yeast to produce zymase, maltase enzymes for the conversion of glucose and maltase respectively for production of ethanol and carbon dioxide. Here we observed that the radiation exposure did not have any significant effect on the ability of the microorganisms to produce carbon dioxide. However, we saw that yeast is able to metabolize glucose faster than maltose. And in this method, we use two methods: gasometric device, as shown in with the blue instrument there with the syringe. So in this experiment, the same observation were made. Now, in conclusion, the exposure of the yeast to radiation had no decreased the viability, the generative activity, and the fermentation effectiveness of the yeast. Therefore, the exposure of the yeast to radiation had no stimulatory effect on the metabolism or fermentation effectiveness of the microorganism. Thank you.
Thank you so much. Do you have any questions? It's a very interesting presentation. No questions.
I will ask some questions. So thank you very much. For me as a biologist, it's a very interesting topic. I would like to ask you why you have chosen especially yeasts for your investigation. Why not bacteria, algae, cyanobacteria, and something like that? Why?
Right. Okay, our interest is actually to focus on microorganisms that are beneficial in biotechnology used for production of food products. So actually in our first study, we look at bacteria. We focus on lactobacillus and streptococcus because industrially they are used for the production of food products. So Saccharomyces cerevisiae also plays a very crucial role in industry for production of different kinds of products. So our goal was to find a way to optimize the ability of these microorganisms to scale up production. Because if you have a microorganism that is able to metabolize, had a very efficient metabolism, I think a lot of industrial players will be willing to go in for some of these microorganisms. So our focus is to improve these microorganisms that are industrially important to improve their metabolism. That is our goal.
Yeah, and you prove their stability, high stability. Thank you very much. It was a very interesting topic. And now let's move to another online presenter. Let's try. Mr. Kakbet Aaron Kambairo, the PhD students for Department of Construction Organization and Real Estate Management, Institute of Economics, Management and Communication in Construction and Real Estate, Moscow State University of Civil Engineering. Dear Aaron, are you with us? Not yet, because he has text me that it's some unstable connection. Okay, let's move to another online presenter, Valerian Bakharane, PhD students of Institute of the Environmental Engineering, People's Friendship University of Russia, named after Patrice Lumumba. Dear Valerian, are you with us?
Hello.
Yeah, we can hear you. So now we will share your presentation.
Okay, you can share.
Can you see your presentation?
Okay, I see it. Thanks.
Okay.
Okay.
Let's start.
As on the slide, my name is Valerian Bakharane. I worked on this research with my colleague Emmanuel Igwe. We analyzed the sulfur dioxide concentration in East African cities using the satellite remote sensing and the modular analysis. The World Health Organization classified air pollution as the world's largest single environment and health risk, with an estimate of 7 million premature deaths in 2012. While air pollution poses serious harm to the human health and environment, most African countries are still suffering from lack of adequate air quality monitoring networks, and so poorly assess the atmospheric pollution over the territories. However, with the widespread of use of satellite remote sensing and the modeling as the mean of air quality control and the environmental assessment on the global scale, government should no longer rely on ground measurement as the only method for environmental monitoring. This study fixes itself the objective of assessing the level of and variability of sulfur dioxide in 5 East African cities using the satellite remote sense data and the model analysis. Although sulfur dioxide is a normal component of the atmosphere, the current concentration of sulfur dioxide in the atmosphere is entirely anthropogenic, with the main source being the coal combustion and the engineer fuel. As a result, on the figure we see the variation of sulfur dioxide in the 5 cities in East Africa. We saw that the cities of Kigali and the Bujumbura are having the higher concentration, with an instant peak of 2.14 in Bujumbura and 1.83 Dawson unity in Kigali. The figure shows the variability of sulfur dioxide sulfur's concentration. The figure shows the sulfur's concentration and monthly variability during the study period. The highest observed daily value was 2.380 from microgram per meter cube from Kigali city, followed by Bujumbura. Those cities, Bujumbura and Kigali, are near located to the Eastern Republic of Congo, where we have the volcano, Nyiragongo volcano, which is active and is the one of the most sulfur dioxide emitter in the region. The diurnal variability showed that the sulfur dioxide concentration are higher in night time and lower in the daytime local time, of course. This may be justified by the atmospheric stability and the temperature inversion during the night time. As the temperature inversion occurs, the air pollution concentrations are trapped to the ground level and the pollution is poor, while the high temperature will increase the mixing and the lower air pollution level in cities. The figure we see is the monthly variability of sulfur dioxide concentration. Again, we saw that the month of July to October, from July to August, June to August, are presenting a higher value of sulfur dioxide concentration, especially in cities which are Kigali and Bujumbura, where we saw that there are so high level of sulfur dioxide pollution. Of course, the dryness of a region also contributes to the monthly variability of concentrations we saw in the previous slide. As a conclusion, we used 10 years satellite observation and model analysis to assess the level of and the variability of sulfur dioxide atmospheric amount and the mass concentration in East African cities. The cities of Bujumbura and Kigali present the high value of sulfur dioxide pollution in dry months are more polluted than the wet ones. The limitation of the study was of course, due to the time we had, we didn't manage to get surface monitored data so that we can assess the uncertainty of the satellite and the model analysis in reflecting the real pollution on the ground. We also lacked the local emission inventory to link the pollution observed with the sources, the local sources, especially technology sources. Thank you for your attention.
Thank you so much. And do you have any questions? Please.
Thank you very much for your presentation. My question has to do with, is there a solution to reduce the CO2 in the atmosphere since it's a source of air pollution? Thank you.
Yes, we have some measures. I think the East African community since 2015 limited the content of sulfur content in the fuel, especially by 50 part per billion in diesel and 150 part per million in gasoline. This, of course, may be the source also the source of the lower pollution level we observed during my presentation.
Okay, thank you for your answer.
Any questions? I have questions. What is the main atmosphere anthropogenic source of sulfur oxide in the atmosphere of cities in East Africa? Anthropogenic.
The main anthropogenic may be the mining, activities which are mostly in country Tanzania, in Zambia, and the DRC, Republic of Congo.
Thank you.
And let's move to the next presenter, Nyamba Betkahol from Nigeria. It's master student of Institute of Environmental Engineering, People's Friendship University of Russia. Please, the floor is yours.
Good morning.
And please remember about 6 minutes, please.
Okay. Good morning. My name is Obed, and I'll be doing the application of remote sensing techniques in monitoring organic pollutants in Africa. And I'll be doing this alongside with Shaibu Ochoche. All right, so we are talking of pollutants because this is really what has affected Africa and is really affecting Africa in recent times. And we're looking at the possible ways that this will be controlled, especially using remote sensing techniques. So Africa, as we know, is embedded with a lot of mineral resources that are buried beneath. And every country in Africa has one or several mineral resources underneath. And in the process of mining these resources, a lot of inorganic materials pollute the environment, and they cause a lot of nuisance to the environment, which affect both the fauna and the flora species. So just like I said, Africa is major producer of many of these mineral resources, and this cuts across every part of Africa, and it contributes to the global resources that other countries are really coming to Africa to get. And there's a statistics that shows that the emerging market in Africa is from these mineral resources, just like the leading mining companies in Africa by market capitalization. In billion dollars come from Africa, and this is because of the increasing exploitations of these mineral resources, and this contributes to the pollution that is occurring. So there's need for the control of this the control of this pollution, and one of the ways for this is the use of technology. So remote sensing is a powerful tool that can really do this and help us to monitor and assess the effect of these mineral resources on the environment, and also to see the possible ways that this can be controlled through implementation of policies and other ways. So let's look at remote sensing. It's the acquisition of information about an object or a phenomenon without making physical contact with it. And of course, it has to do with the use of sensors, which can be mounted on aircraft or on using the space or the satellites, and this get information real time on the Earth surface. using the EMR, which is electromagnetic radiations, as they make contact with the Earth's surface. So looking at the remote sensing, we know that remote sensing techniques enable the identification and mapping of areas affected by inorganic pollutants, and this can be done using multispectral and hyperspectral remote sensing data. Talking about multispectral image, multispectral and hyperspectral, there are different. Every inorganic material has different reflectances in hyperspectral image. So you can be able to dictate that as those images are being taken and analyzed through those using the appropriate tools. So it can be easy to indicate, to really know which particular inorganic element is or mineral is actually polluting the environment at various places. So this can be used in the mining areas and the mining places. You can actually take some of these readings using the remote sensing technology and be able to dictate the level and the extent to which this is affecting the environment. So talking about the soil and the vegetation analysis, because when this happens, it affects, I said it affects both the fauna and the flora species. So when you are looking at the effect on the vegetation, you can use various indices, which one of which could be NDVI, which is the normalized differential vegetation index, which helps in actually knowing the extent to which these pollutants affected the plants and look at the progress of the plant at various points. So this can be determined, and of course, it affects both the water too, the hydrological monitoring, which has to do with the use of the WQI, which has to do with the water quality index. You can also use that to dictate the extent to which this pollutant have affected the water, and several others. So of course, this can be done. This can be done. I missed my slide. Right. So let's move on. So looking at the radar, when we talk of the radio detection and ranging, it has to do with the satellite sends down a radio wave which goes down, hits the object, and comes back. And the feedback depends on the frequency of the radio wave being used. So this comes down from the satellite, touches the ground, and as you can see from the slide. So, and also we have the hyperspectra, which has to do the difference between the hyperspectral images and the normal images that are, and it, of course, it is not limited by the red, the green, and the blue colors, but captures thousands of colors within the beam of light. So just a beam of light gives you the different reflectance that this makes contact with. So however, not all the hyperspectral images are the same, and that is what makes it unique in picking up which of the inorganic materials that are polluting the environment. So looking at one of the recent or let me say the advanced remote sensing technology, which is actually very scarce and of course very expensive currently, is the LiDAR, which has to do, which is the light detection and ranging, and basically three-dimensional advanced in operation, produces images in 3 dimensions, provides a lot of data in its images. Let's look at the case study, and I'll be able to say 1 or 2 things before I round up.
Okay. This is the case study of Plateau state in Nigeria. Is located in the central part of Nigeria, and if you look at it, there is a much abundant of these mineral resources deposited in this state, and the activities of individual, the miner, causes a lot of havoc. If you can see how people are going about extracting of this mineral, and with this, the research have it that about between 1,000 to 4,000 abandoned things and columbine mines that pose serious health risk to more than 2 million citizens of this state. Because the reason for this is that some of the miner, when they start the process of mining, along the line, they dull the process because they could not be able to conclude or do effective cleanup in the process. So that send a lot of danger to the environment. And the second case study of gold mining in Ghana, a country in West Africa, it also shows that mining also have a significant pollutant pollution to the environment, because if you look at it, the process they take go deep extracting this mineral causes a lot of havoc, because some of them use a very crude tools, not a modern these things. And so with that, this old, as in a crude method of extractions, it impose so many challenges to environment, because they could not be able to use their ordinary knowledge to extract this mineral very well and then control the environment. So that has a lot of challenges.
All right, just as a conclusion, remote sensing offers a cost-effective, scalable, and comprehensive approach to identifying pollution sources and monitor remediation effects, because most of these places are not accessible, and you cannot really be able to assess and monitor the effect of this pollutant in the environment. So remote sensing gives us that. Ultimately, it helps in the application of remote sensing in monitoring this pollutant and help us in taking proactive decisions in providing a healthier environment in Africa. And then I have these few recommendations that I want to make, that African countries can harness the full potential of remote sensing techniques in addressing the challenges posed by inorganic pollutants through the following: strengthen the research and collaboration, enhance data accessibility and quality, invest in technological advancement, promote capacity building, and incorporate remote sensing in policy frameworks, which will actually help in calming some of these things, because of course there are some diseases that affect even the human beings, that actually reduces the life expectancy of people in Africa. And then looking at it, they should also encourage public-private partnership that will enhance the use of this technology in effectively controlling the inorganic pollutant in the environment. Thank you so much for listening. These are my references.
Thank you very much. Thank you very much for your interesting topic and very perspective recommendations that you have mentioned. So, dear colleagues, it is left two reports, and I propose 5 minutes for each other. Please respect these 5 minutes, okay? And the next presenter.
The next presenter is from Nigeria, Osayoji Osazemen Godswill, master student, Institute of Environmental Engineering, People's Friendship University of Russia, and topics names turning trash into treasure, the energy potential of waste in Nigeria.
Good day, everyone. My name is Osayoji Osazemen Godswill. So I'll be presenting on the topic turning trash to treasure, the energy potential of waste in Nigeria.
Please louder.
Okay, this is my table of contents. Introduction. The need for efficient and sufficient energy supply has brought about a great interest in renewable energy generation. The energy potential of waste is the least discussed source of energy compared to other sources like the wind, the hydro, and the solar, as well as nuclear energy, as my colleague, Dr. Anthony said. Why? This energy potential, what does it really mean? It's also called waste to energy or energy recovery. It's simply the process of producing heat, electricity, or fuel from non-recyclable waste materials. Waste arises from human activities, as we all know, such as domestic waste, commercial waste, industrial waste, and agricultural waste. These wastes, if they are not channeled into resourceful or useful application, if they are channeled into resourceful and useful application, they can make meaningful contribution to energy generation. But when they are not properly utilized, it will have a great impact on the living conditions and our environment. The type of waste that is being used are called municipal solid waste, which contains glass, paper, plastic, food waste, and wood. Next, the waste management hierarchy. These are set of priorities that are used in managing waste in an environmentally stable condition. The most preferred option is to prevent waste, and the least preferred option is to dispose waste in the landfill. There are 5 stages, while recovery have to be is in the 4th stage. And the other stage, which are the reduce, the reuse, the recycle, and landfill. Next slide. Why the municipal solid waste generation of cities in Nigeria. According to the United Nations Industrial Development Organization report, Nigeria generates 41,000 tons of waste daily and 42 million tons of waste annually, accounting for 2.5 million tons of waste, plastic waste. These are some of the cities in Nigeria, and this chart shows the waste that is being generated per month. Nigeria still range from 10,000 tons to 260,000 tons per month. The generation of waste depends on the city's population. Those with high population are more likely to generate more waste. From the chart, you see that Lagos and Jos generate more waste because they are the most populated in the country. Next, the types of municipal waste generated in Nigeria. You can see the percentage and the tons that is being generated per year. The high tons of waste is available for energy generation, which will be of immense benefit to both domestic and commercial consumption. Next slide. The waste to energy recovery method used in Nigeria. First, we have the incineration. This is the most used waste management technique that is being used. The heat is used to produce heat that drives the generator to produce electricity. This approach has several advantages. One, it reduces the waste volume, it lessens transportation costs, and decreases harmful greenhouse gas emission. Secondly, we have the anaerobic digestion. It's a biochemical process that breaks down organic waste with the absence of oxygen to create biogas. These biogas are the main source of renewable energy used in the world today. This biogas result from AD is mainly made up of carbon dioxide and methane. The very same methane that arises from landfill, though here it is of use for a purpose. These biogas are used as source of transport for heat and electricity. The other product of the AD process is the digestate, which is a solid or liquid substance that can be used as source of fertilizer. Next, we have the gasification. This works by processing waste at extremely high temperature, which produces char and combustible natural gas, which is the biogas or the syngas. This gas is being used as source of fuel and the byproduct as source of fertilizer. We also have pyrolysis. This process is widely used in the industrial process to create energy from waste. It uses organic or agricultural waste from industry. These waste are used to produce charcoal briquettes, which have many domestic and industrial applications like eating and cooking, like the popular one which is used in preparing barbecue, as you can see. While the gasification and the pyrolysis are two similar methods, both of which decompose organic waste material by exposing waste to low amount of oxygen and very high temperature. The main difference is that pyrolysis uses absolutely no oxygen, while gasification allows a very low amount of oxygen in the process. While these are some biogas stations plants in Nigeria. We have one in Ikorodu, we have one in Kano State, we also have in Ebonyi State. While the benefits, it has economical, social, and environmental benefits. For the environmental benefits, they conserve natural resources and ecological quality. It promotes proper waste management. It reduces pollution and emissions from poor land filling or open dumping. It reduces land use for new land fill and open dumps. It supports climate change and reduce financial burden of waste management. While for the economic benefits, value-added product service, which contributes to the country's GDP, it also contributes in job and employment creation. While for the social benefits, it creates pleasing and livable cities, more financial resources to fund other social amenities, help resolve social depletion, induce community conflicts. While the waste to energy in Nigeria is not fully harnessed due to some challenges. Some of the challenges are: one, finance, poor public and private investment, poor funding of management are crucial for improved collection, while the attitude, poor awareness of waste usefulness, indiscriminate disposal method, while we also have poor waste management, non-sorting of waste, poor waste collection efficiency, insufficient policy and infrastructure, but we also have technology, lack of proper and relatively inexpensive automated sorting and recycling technology, poor transportation network. We also have the regulatory framework, non-recognition of informal sector in waste management, exorbitant levies and permits on the recycling operators, inconsistent and uncoordinated government policy. Well, in conclusion and recommendation, population increase, urbanization, economic growth, and consumption is causing huge amount of municipal waste generation in cities across Nigeria. However, the waste are not properly disposed, causing environmental pollution. Energy production for municipal waste, solid waste, should be established as a crucial part of an integrated waste management strategy, while at the same time producing energy. This will aid in mitigating greenhouse gas emission and support climate change policies. Thanks for listening.
Thank you very much for such interesting topic. Of course, the circular economy is one of our trends and perspective. So I suppose that our section can be closed. All the report has been reported, and I would like to express your great gratitude for your job, for your presentation, for your interesting vision of different environmental issues. And I hope this event was useful for you, and maybe you will get some academic tie from different universities. We have the representative of the Ural Federal University, Tomsk Polytechnic University, Moscow State Construction University, and People's Friendship University of Russia. And our guests from online, they also, I suppose, that are available for some academic interactions. So thank you very much for your time and your efforts. And the section Ecology in frame of this forum is closed. Thank you.